This is lessons 10.3 and 10.6. So in the same or congruent circles, arcs are congruent when the corresponding chords are congruent. So what that means, if in the same circle, if I had two different circles that were exactly the same because they had congruent radii, if chord FG and chord JH are congruent, that makes arc FG and arc JH congruent. And the reverse is true. If arc FG and arc JH are congruent, then chord FG and chord JH are congruent. So here we have a pair of congruent circles. They tell me that circle A is congruent to circle B. And we know that arc WX is congruent to arc YZ. So that would mean these two chords that made those arcs are also congruent. So 7x minus 2 would equal 5x plus 6. 2x equals 8, and x is 4. And if we want to find WX, we could do 7 times 4 minus 2. So WX equals 26. In the same or congruent circles, chords are congruent if they are equidistant from the center. So that means if this little segment here and this little segment here are the same, that makes these two chords the same. And the reverse is also true. If the two chords are the same, they will be the same distance away from the center. Remember, distance from a point to a line always has to be measured with the right angle. If we don't have the right angle there, we cannot determine that those are in fact equidistant. So in example 2, we know that EF and GH both equal 24. We want to find PQ. So EF and GH are two chords that are congruent, which means that they are equidistant from the center. PQ and PR would have to be the same. So I'm going to set them equal. So 2x equals 6 and x is 3. And now we want to find PQ. So we could do 4 times 3 minus 3. PQ equals 9. If a diameter or radius is perpendicular to a chord, it bisects the chord and the arc. So if either radius CB or diameter AB is perpendicular to chord XY, that means the chord got cut in half and the arc got cut in half. And also, if we know that we have a segment that is the perpendicular bisector of a chord, that segment must be part of the radius or the diameter. So example 3, in circle S, the measure of arc PR, so here's arc PR, is 98 degrees. And we see that TR here is 6. We want to find the measure of arc PQ. So PQ is going to be here. Since QS was the perpendicular bisector of this chord, it's the perpendicular bisector of this arc, meaning 98 got cut in half. And the measure of arc PQ is half of 98, or 49 degrees. And the length of PR, since these two pieces are the same, they're both 6, so the whole segment PR would be 12. So here's a try for you to do. Pause if you'd like. Answers are posted online. Example 4. We have a stained glass window. The diameter GH is 30 inches, and the chord KM is 22 inches. We want to find both JL and LH. Those are two pieces of a radius, but they are not equal pieces of the radius. So I'm going to look at this picture without all the stained glassedness in it. I am going to add the little right angle symbol because that was in the other picture. So the whole diameter GH is 30. I'm going to put that to the side for now. We don't need to know that just yet. But that does tell me that the radius is also 15. Right? If the diameter is 30, the radius is 15. We're told KM is 22 inches. So since this chord KM was perpendicular to this diameter, we can assume that that 22 was bisected. So each of those pieces is 11. Let's start by saying we want to find JL. I'm going to move my little right angle symbol to the other side. Let's say I want to find JL. I can create a right triangle by introducing another segment because I know the length of that segment. What I've just drawn is a radius, and every radius in this picture is 15. So it didn't matter where I drew it. It could go to any point on the circle, but if I drew it to K or to M, I've created a right triangle for myself, and I can use the Pythagorean theorem to find the missing side. So we know 15 is the hypotenuse. So 15 squared equals x squared plus 11 squared. So we're going to get 104 equals x squared. I'm going to guess this is a little bit more than 10. And it is 10.2. So that means JL is 10.2. And now we still want to find LH. LH is the rest of the radius that JL started. So JH, this whole thing here, was a radius of 15, and we just found that JL was really 10.2. So if I do 15 minus 10.2, LH would be 4.8. Right? So you might be asked to find JL. You might be asked to find LH. If you want to find LH, you'll have to find JL first. If you want to find JL, you don't need to find LH, if that makes sense. So here is one for you to try. Pause. Answers are posted online. If chords intersect inside, well, it's the only place chords can intersect, but if we do have two chords that we see intersect, the products of their pieces are equal. So when I have lines intersecting inside the circle, I'm going to multiply the pieces of those segments by each other and set them equal. So what that means is this piece of the chord AB and the other piece of that chord BC are going to get multiplied by each other. This chord piece EB will be multiplied by this chord piece BD. So we're multiplying the two pieces that made up the one chord and setting it equal to the multiplied version of the two pieces that made up the other chord. So here in example 5, I'm going to start on this chord. I have the two pieces are x and 8. So x times 8 equals, two pieces of this chord are 12 and 9. So we're going to get 8x equals 108. And when I divide 108 by 8, we get x is 13.5. For the other one, we have x and x plus 10. I'm going to put x plus 10 inside parentheses so I remember to distribute. And the other one is x plus 4 and x plus 2. I'm going to put both of those in parentheses so I remember to distribute. So on this side, we're going to have x squared plus 10x. On this side, x times x times 2, 4 times x, and 4 times 2. Really nice. Our x squareds on this one are going to cancel out. So we have 10x equals 6x plus 8. So 4x equals 8 and x equals 2. So here's some for you to try. Pause. Answers posted online. Example 6. The true shape of a rainbow is a complete circle. However, we only see the arc of the circle that appears above Earth's horizon. What is the radius of the circle containing the arc of the rainbow shown? So they're giving me a chord that has been bisected perpendicularly by something. We can assume that something is part of the diameter or the radius. So I have redrawn my picture here to show that that 0.7 up there could continue all the way through the circle to be the diameter. I'm going to put the center there to show that that was the diameter. And because this 5 miles was bisected, each of these pieces is 2.5. So while I can't find the radius or the diameter right now, I can make the rest of this segment a variable. And now this is two chords that intersect inside. I'm going to do piece times piece. We're going to do 0.7 times x. I'm going to do 2.5 times 2.5. So we're going to get 0.7x equals 0.25. And when I divide by 0.7, I'm going to get a decimal. 8.93, we'll say. So that's what this segment here is. That's not the radius. That's not the diameter. The diameter would be if I added 8.93 plus the 0.7. So the diameter is really 9.63. But I'm still not done because I wanted the radius. We know the radius is half of the diameter. So if I cut this in half, we get 4.81. And there were units in this problem, they were miles. For try 6, you're going to draw the same kind of picture. Pause. Answers are posted online. If two secants, or a secant and a tangent, intersect outside, the products of the whole segment and the part outside are equal. So we're going to do the piece that's outside times the whole thing, the piece that's outside times the whole thing. On this one, again, piece that's outside times the whole thing, piece that's outside times the whole thing. There won't be anything to combine here because the part that's outside is the whole, but we do still have to do outside times whole, even though it's the same number. So it's just going to be that number squared. So for example 7, the piece that's outside is an x, and this whole segment is x plus 9. On the other side, the piece that's outside is a 4, and the whole segment, 4 plus 5, is 9. So we're going to distribute x squared plus 9x equals 36. We're not so lucky this time. This is a quadratic. We have an x squared and an x. We are going to have to factor, so let's get it equal to 0. So x squared plus 9x minus 36 equals 0. We're looking for the two numbers that multiply to negative 36 and add to positive 9. That's a positive 12 and a negative 3. So that means x would equal negative 12 and x would equal positive 3. Since this x represents an actual length in the picture, it cannot be negative. So our answer is x equals 3. Another one for us to try together. The part that's outside here is x. If I wanted to add these pieces together, that's x plus 2 or 2x plus 2. And here the part that's outside is 12, but also the whole thing is 12. So we're going to get 2x squared plus 2x equals 144. I'm actually going to divide everything by 2 first. I'm going to get x squared plus x equals 72. And now I want to factor this. I'm going to get it equal to 0. So x squared plus x minus 72 equals 0. That's x plus 9 and x minus 8 to add to positive 1 and multiply to negative 72. So x could be negative 9 or positive 8. And again, x can't be negative. So our answer is x equals 8. This is the final one for you to try. It is not factoring, so don't worry about that if you don't have to factor. But the answer is posted online, and that is it. That is the end of sections 10.3 and 10.6.